All right, guys, we've learned how to graph linear functions. So the next logical step is to be able to graph linear inequalities. Same graphing as we've done before, except we're going to shade it, and you might use a dotted line sometimes instead of a solid line. All right, so you can write down the definition of a linear inequality. All right, just relates two variables, so x and y, to each other using an inequality symbol. It's our greater thans and less thans. Okay, the solution set, all right, it's a whole set of numbers. It's not just one single value. The solution set is a region of the coordinate plane bounded by a line called the boundary line. All right, so let's graph these. They're already in slope-intercept form, so that's good for us. Remember, we want to start by plotting the y-intercept, and then we'll use our slope as a rise over run. So y-intercept is positive 2. Plot that point there. And then my slope, I'm going to move that negative up to the top. You could put it on the top, you could put it on the bottom, just as long as there's only one negative there. All right, and that's going to be my rise over my run. So negative 1 says to go down 1, positive 3 says to go right 3. Do that a couple times, down 1, right 3. Okay, if we had put the negative on the bottom, we would have gone up 1 and then left 3. And you'll see that that also stays in line. Now, when we go to graph our line with inequalities, we have to decide whether it's a dotted line or a solid line. So the regular inequalities, the regular greater than, regular less than, that's a dotted line. And the equal to inequalities, greater than or equal to, less than or equal to, those are our solid lines. So this one's a regular greater than, so it's going to get a dotted line that goes through these points, like that. All right, and then we have to shade. Okay, we're going to shade above the line when it's greater than, and we're going to shade below the line when it's less than. All right, so y is greater than, so above the line would be all of this up here. Shade all of that. All right, it wants us to choose a point in the solution set to test our answer. So I need to just pick a random point out here and plug it into the equation and make sure it works. Now I'm going to pick something that has a 3 as my x, because that'll easily multiply with 1/3. 3 times 1/3 cancel each other out. So let's see, I'm going to do 3, 2 right here. That's in our solution set. It's in the shaded area. So I'm going to plug in 3 for x and 2 for y. So this is a 2 is greater than negative 1/3 times 3 plus 2. Okay, the 3 and the 3 cancel. So that's 2 greater than negative 1 plus 2. And negative 1 plus 2 is 1. So is 2 greater than 1? It is. So we know we've shaded the right area. All right, that's just to be safe. All right, in case you're ever worried you may have not shaded the correct area. Okay, you can choose that. The dotted line signifies that points on this line are not solutions to the problem. Okay, so if you picked an actual point on this line, so like this one over here is negative 3, 3. So we'd have, negative 3, 3. So 3 is my y, greater than negative 1/3 times negative 3 plus 2. So if you multiply negative, the negatives cancel, the 3's cancel, so that's positive 1 plus 2. 3 is greater than 1 plus 2, so 3 is greater than 3, which is not true because it's not equal to. Okay, so it'd have to be equal to. So that's why we do the dotted line, to signify that it's not equal to the line. Only points above the line count. All right, why don't you give this one a try on your own? All right, and then we'll unpause the video and see how you did. So plot negative 2, rise over run, so that's 3 over 1 is our slope. 3 is our rise, 1 is our run. So rise 3, 1, 2, 3, run 1. Rise 1, 2, 3, run 1. Okay, it's an equal to, so we do a solid line, so draw a solid line through those. And then we want to shade above. Now it's a little trickier with these steeper slopes, which one's above, which one's below. So always pretend that whatever way the line's tilting, so it's tilting to the right, that if you have flattened it out, If I tilted it to the right so the line was flat, what would be the above side? The left side would be above if I turned that graph. I'm like doing hand motions and y'all can't see them, but if you turn the graph to the right so the line was flat, then it would be this section that was greater than. All right, but remember, we're going to choose a test value anyway. Okay, so if you're ever confused, like, oh, I'm not sure, you're going to do a test value. I'm going to use 0, 0. I always try to use that one if it's an option. It wasn't an option on the last one because it wasn't in the shaded area, but this time it is. So plug in 0, 0. 0 is greater than or equal to 3 times 0 minus 2. All right, 3 times 0 is just going to cancel. So this is 0 greater than or equal to negative 2. Yes, it is. So we know we've shaded the right area because our test point worked. All right, next thing we're going to do is vertical horizontal lines. Okay, I've seen some struggles with this on our last test when we were doing just equations. Okay, so I want to make sure we review this really well. Okay, y, when it's y equals, or in this case less than just a single number, this is a horizontal line. Okay, commit this to memory. Okay, because these should be super easy. Once you remember which one's which, super easy, horizontal line. So we need to draw a horizontal line through 3. All right, that's 3 right here. Okay, it's going to be a dotted line because it's not equal to. So I'm going to draw a horizontal dotted line. All right, and the horizontal lines are super easy for inequalities because it's very easy to tell what is above and what is below. All right, this is the above section, but we want to shade less than, so we want to shade the below section. All right, if we choose a test value, again, I like to use 0, 0 if it's an option. Okay, 0 is the y value, is less than 3. Is that true? Yes. So we know we've shaded the right area. All right, x is greater than or equal to negative 7. All right, so it's going to be a solid line through negative 7. All right, so 1, 2, 3, 4, 5, 6, 7, right there. Let's do a little bit thicker line. All right, draw my arrows on that. All right, now this one you can't really go with above or below. That's why I want to show you this, because it's vertical. There's only a left side and a right side. So think about the x-axis. All right, which side is greater than, which side is less than. In fact, you can think of the number line graphs that we did when we did compound inequalities. Okay, when it's less than, it shades to the left. When it's greater than, it shades to the right. So this one is greater than or equal to, so we want to shade the right side of this vertical line. All right, you can choose your test point there, 0, 0. We're only going to use the x coordinate because there's no y. 0 is greater than or equal to negative 7. That is true, so we've shaded the correct area. All right, word problem. Okay, it's going to ask us to write an equation, then we're going to make a graph, and then we're going to answer this question over here. So the school carnival charges $4.50 for adults and $3 for children. The school needs to make at least, there's a key word, $135. So 4.5 times A plus 3 times C at least greater than or equal to 135. All right, now this is in standard form, which is not a good form for graphing, so I want to convert it to slope-intercept. That means I need to get one of these two variables by itself. Okay, I'm going to choose C. C is going to be my y in this problem, and A is going to be my x. All right, so I'm going to subtract 4.5a from both sides. So I have 3c greater than or equal to negative 4.5a plus 135. All right, still got to get c by itself, so I'm going to divide by 3. All right, I'm dividing by a positive number, so don't flip the sign, just still stays greater than or equal to. All right, negative 4.5 over 3 reduces to negative 3 over 2a, and 135 over 3 is 45. All right, so my y-intercept is 45. My slope is negative 3 over 2. All right, so I'm going to go by 5s on my graph here. 5, 10, 15, 20, 25, 35, 45. All right, and as long as I go by the same scale down here, I can do my slope like I normally do. So I'm going to go by 5s down here as well, because that's going to make life much easier on me. Okay, so I don't have to like count down 3 and then over 2 and go like that. You can literally just count 1, 2, 3, down 3, right 2. And the reason this works is because it's technically negative 15 when we go down 3, but it's over positive 10. And if we reduce that, divide both by 5, it reduces to negative 3 over 2, which is what our slope is. So that's why you're allowed to do this. But it only works if it's the same scale. So make sure you have the same scale. All right, 1, 2, 3, 1, 2, and 1, 2, 3, 1, 2. Okay, this is actually going to be the only part of my graph. We have an equal to, so we're going to use a solid line. Okay, I'm not going to go into this section or this section because this is a real world problem. I can't sell negative numbers of tickets. Okay, so it's only in the positive quadrant. Okay, let's make sure we label this as well. So down here we have the adults, because I used A was my X, and over here we have the child tickets, because C was my Y. All right, and then we're going to shade above, because we're greater than or equal to. All right, so any point out here would be in our solution set that would cover our expenses. Now they want us to answer this question specifically. If we sold 25 child tickets, how many adult tickets must be sold to cover expenses? All right, so I'm going to you can use either equation. I'm going to use our original one up here, this one. All right, I'm going to plug 25 in for C. So that's 4.5A plus 3 times 25 needs to be greater than or equal to 135. All right, so 3 times 25 is 75. So if I subtract 75 from both sides, I get 4.5A is greater than or equal to 60. And then I divide by 4.5. And you get A is greater than or equal to 13.3, and it's repeating. All right, the reason I'm putting it in decimal form is because we can't have a decimal answer. All right, we're selling tickets. You can't sell a third of a ticket. Okay, so it has to be greater than or equal to 13.3, which means they have to sell at least 14 tickets. We can't round this down to 13 because 13 is not enough money. All right, they have to have over 13, so we have to round it up to the next one. So our answer for this would be at least 14 adult tickets.